The polar form of a complex number, example 3. We're asked to express this complex number in modulus argument form. This is another word for polar form. Every number can be expressed in terms of its modulus, or, and its argument, theta. If we draw a sketch of the number, 1 minus root 3i, we might have a sense of what this modulus and argument mean. We know that this is a number that has a real part of 1 and an imaginary part of negative root 3i. Negative root 3 is approximately 1.7. We could use that to roughly sketch this. So we can see that the number 1 and negative root 3i is in the fourth quadrant of the argand diagram. We could see that it has an argument of theta, and it has a modulus or size. We could use this triangle, right angle triangle in Pythagoras' theorem to work out the size of r, because the triangle has sides of 1 and root 3, and we could work out that r is equal to 2. Or we could use the formula, which is a version of Pythagoras' theorem, which says the modulus is the square root of a squared, which is 1 squared in this example, plus b squared, which is root 3 squared. We can see that this is the square root of 4, which is 2. So we know in this triangle, the modulus is 2. I'm going to work out this angle alpha inside the triangle. This will help us work out theta. I can see that tan alpha is root 3 over 1. Therefore, alpha must be tan inverse root 3. We might recognize that tan inverse root 3 is 60 degrees. We might recognize the triangle. In radians, it's pi over 3. You can use a calculator to help you with this as well. Now, this is not theta, but it relates to theta. In a positive sense, theta is what is drawn, but we could also express theta in the negative angle, so going in the clockwise direction from the positive sense of the real axis. Therefore, we could call theta negative pi over 3. It's negative alpha. So now when we go to express our number in polar form, we know its radius is 2. So it's 2 by cosine of our angle minus negative pi over 3 plus I sine the argument angle negative pi over 3. That's the number expressed in polar form.